Okay, folks, I want to take a look at this week's lab, jump out in front of possibly some questions that you might have. So I'm in the female height tab down at the bottom. Let me grab this here. Down at the bottom here where it says female height on the tab down there. I want to be on that tab. I'm going to look at the female heights. I want to make the histogram and show you some differences that you might see in the histogram it initially creates for you, and maybe we can get one that looks a little bit more like this one. You don't need to worry about having this density curve placed inside of there. That's not super important for what we're going to do. Okay, so if before I go to insert and look for the histogram chart, if I just simply highlight the list, I'll select the list of female heights so that it's highlighted like that. Now when I go up to insert and find charts, and histograms, as I remember, used to be a lot more complicated in Excel, so you definitely have changed this. You had to pick bins and a whole lot more heavy lifting to get this set up. So down here on my list I have histogram. When I click on it, I kind of get a preview of what it looks like. It's similar to what you have on the page, but definitely there are some differences. Remember, the purpose of a histogram or even a box and whisker plot is for us to look at a variable and assess the center, the shape, and the spread. So the center generally is going to be a number that's going to summarize. Like if I want one number, the mean or the median, that would summarize the set of data, that's my center. The shape, especially in this chapter now, we're focusing in on this very specific shape, a normal shape, which is that mound-shaped, symmetric bell curve that you saw superimposed. But if a distribution is skewed to the right, like suppose professional sports salaries in a lot of sports are skewed to the right, you have a couple people that make a lot more money than everybody else, and that would make the mean higher than the median. Maybe you're looking at house values, and there's a couple of rundown bank-owned properties in a pretty nice neighborhood, and they're bringing the average price down. That would be skewed to the left. But what we'll start to see as we move through the rest of this course, this normal distribution, this normal shape, as it relates to the central limit theorem, which we'll study in a couple weeks, summarizes a lot of variables in this particular shape. So I'm just going to go ahead and click OK, right, and I get this histogram, and it doesn't look exactly like this. So the one thing that maybe we notice that's different is this histogram here has less bins. There's 1, 2, 3, 4, 5, 6 bins. The idea with the histogram is that we have we want to divide. This is always a quantitative variable down here. Down here it's labeled. It tells me, what numbers fall in this first bin. Any number between 147 to 150 is in this bin, and so on. So this histogram has more bins. So one of the things I want to show you is how we can change that, change the number of bins. Okay, so if I double click down here where I can see the bins are divided up, and double left mouse click, let me slide this over so you can see what just popped up, I get this box format axes. Okay, and right here we have number of bins. So if I want to change that number of bins, right, we had 1, 2, 3, 4, 5, 6 bins. I'm going to click on number of bins and change that 10 to 6. Okay, and Excel will automatically update that, and now I have a good bit closer breakdown. I mean, really the exact same shape. Okay, the only difference here that you'll notice is the scale on the axis. Okay, this histogram that I have sitting here in the lab is relative frequency. So instead of it telling me actually how many females, like this tells me this is 90 females fall in this category, this tells me that number 90, this gives it a little bit more significance, is over 60%. Okay, of the folks that are in that, or the heights that would be in that category. I'm sorry, not 60%. It's 35%. I saw 6 over here, but that's a second decimal place. Okay, so more like 35% would fall into that. So you have frequency here and relative frequency. Don't worry about changing that. Okay, again, all we want to really do is talk about the center, shape, and spread. We want to see the basic characteristics of that normal distribution. One of the things we'll start to see is that if I find the mean of a set of data and I add a standard deviation or subtract a standard deviation, about 70% of the observations will fall in that portion of the graph. So this is probably 70% of all of my data, and then over here, same idea, like roughly 70% of all of my data. I can almost add them together in my head. A little over 35%, a little over 30%, add those two together, we're close to that 68% number.